Hey everyone, welcome back. I wanted to make this video just to give a little bit of a hint on a way that I would approach analyzing essentially this lab. So we have basically 5 different structures that we're investigating: BCC, FCC, CSCL, NaCl, and diamond. And if we look at our lab handout, we have more mystery materials, A through all the way through H, then we do have ICSD kind of databases, which are 5 of them. Now, obviously, 2 of these text files are going to end up to be polymers, PMMA, or PEO, or PEG, and that's going to be based on the width of those peaks, with PMMA obviously being the much more amorphous material, should have wider peaks, whereas PEG or PEO should have much narrower peaks to indicate, but still wider than metals, to indicate that long-range order indicative of semicrystalline materials. So what we have to do is we need to match which material here in the text file is correlated to our ISCSD database, for example. So that is quite I mean not quite easy, but we're going to be able to figure that out based on really simple, or not simply, we're going to be able to do that by matching effectively the peaks that we observe there. So that, I think, is a little bit more straightforward to match which mystery material corresponds to the card. Now, after we do that, we have to figure out, one, what is the structure of this particular card and the material that we're working with. Well, we see they're very sharp peaks, so these are for sure metals. But is it BCC, is it FCC, is it NaCl, is it CSCl, or is it diamond? So to first determine which structure it is, we have to look at those selection rules. And we have this table here that I've just developed after deriving those selection rules, and we've done several together, and I'm confident that you all can derive those in your own lab and make sure that you're able to describe it. But here are the selection rules for our material. So when we're trying to figure out, well, what material could, or what structure could be, that ICSD JPEG? Well, let's start and look at and compare. I'm going to download it here, and let's do a little side-by-side. And this is what I would do if I were approaching this lab myself. So I'm going to put this down. We're going to do a side-by-side comparison. Hopefully it'll be wide enough to kind of read carefully. So let's go ahead in here. And let's go, and we're going to focus in. These are my selection rules of the peaks that will appear. The red is BCC. So BCC says that if my H plus K plus L is even, I get an intensity. If they're odd, I don't see anything. So let's look. I've got 1 plus 1 plus 0 is 2. That's even. 2, good. 4, and 4 here. So this is looking promising, just like we did last time. But let's compare. Okay, so BCC is a candidate. It matches what we're looking for. What about H, K, and L? Well, okay, they need to be all even or all odd. Well, to see a signal for FCC. So if we look over here for FCC. Well, all even or all odd? No, these are mixed. So off the bat, from the first one, it is not FCC, guaranteed. So this is still a candidate, this is dead. What about the next one? Here, we see if H plus K plus L is even, we get this amplified if it's CSCL structure, we get this amplified peak, and if it's odd, we see this smaller peak. Well, there are no peaks here where H plus K plus L are odd. So right after the bat, that's not going to work. So it is not CSCL because I don't see those odd peaks. We just see even. So no. What about NaCl right here? Well, first, our H plus K, our H, K, and L all have to be all even, or they all have to be all odd. So they can't be mixed effectively. Otherwise, I'm not going to see a signal. So this is mixed, evens and odds. So dead, dead. So it's not NaCl. What about diamond? Same condition, all even or all odd, H, K, and L. And these are mixed. So by process elimination, this has to be BCC. Let's look at one more just to kind of hammer this home. And again, it would be nice if you had something pop up where, for example, to destroy this argument, I would have like a little circle pop up in your presentation to kind of illustrate that this violates effectively those laws. So let's go to another file. Not that file. Let's do 3, for example. Let's download 3. And let's drag it over here. So, then let's put it over here. All right, let's get this guy out of here. All right, let's go through this one. So, h plus k plus l has to be even for BCC. 1 plus 1 plus 1, that's 3, dead. Doesn't work. For FCC, all even or all odd. So these are all odd, all even, all odd, all even. So this is a candidate, for sure. What about here? Here it's saying if h plus k plus l is even, then I get a large peak, a large signal. If it's odd, I get a smaller signal. Well, this is odd, h plus k plus l, but I see a huge peak here. So that should be a small peak compared to this next one, which is 200. That's even. So you see here, I could already throw this. This is not matching what we anticipate to see. What about here? H, K, and L need to be all even or all odd. Okay, we're fine on that one. And if it's even, I should get an amplified signal versus if it's odd. So same thing here, doesn't correlate. That is not true in this particular example. What about here? For diamond. If it's all even or all odd, so that's fine. We get this signal. But if we're all even or all odd, and h plus k plus l is even, so again, this is an odd. If it's even and divisible by 4, I should have a much larger intensity. So if I look at this peak right here, that's around 74 right here, that is all even or all odd. And if I do h plus k plus l, that's even, and it's divisible by 4 exactly, this should have a much higher intensity than this. Boom. Nope. That is not in the works. So that does not work. So that's a way that you can analyze and how you should analyze each of these. Now, once you actually decide on, okay, well, clearly this material is FCC, now I need to calculate my lattice parameter and compare it to the materials that are FCC in this experiment, which, again, if we look on our slides, our FCC materials are either copper, aluminum, or platinum. So that's it. I hope this helps with your analysis, and I'm looking forward to some fabulous presentations. See you all then. Thanks. Bye.